Well, welcome everybody for this third session of CIVICA Applied Data Science Seminar. I'm Giacomo Calzolari. I'm Professor of Economics at the European University Institute. Let me just say a few words on CIVICA, which is a network of universities, and our CIVICA Data Science Seminar Series is a multidisciplinary series focused on application and methodologies for data science in social, political, and economic world. Today, we are very happy to have with us Christo Wilson. Christo is an associate professor. Welcome, Christo. He is an associate professor at Northeastern University. He is a computer scientist, has been worked extensively on many relevant topics for the CIVICA team. And today, Christo is gonna talk about negotiating with AI and fairness in the labor market, which is a very important topic and is also a hot topic nowadays, as we know. Let me just conclude this brief introduction of Christo with the sentence that he wrote that I like very much. Christo writes, he believes that by increasing transparency, we can also improve accountability of these AI systems, I guess. So the rules are, as in the past, 45 minutes for presentation. In the meanwhile, participants can write to me questions. I will collect questions, and then we will have 15 minutes after the presentation for a Q&A session. So without further ado, so let me really welcome Christo, and thanks a lot for being with us today. Christo, the floor is yours.
Oh, well, thank you very much. And thank you everyone for attending. I am happy to be here. So let's get started. Right, so I'm Christo Wilson. I'm a computer scientist by training. I sit in the Cybersecurity and Privacy Institute at Northeastern University in Boston. And I'm a faculty associate at the Berkman Klein Center for Internet and Society at Harvard. Broadly speaking, I wear a bunch of different research hats. Some of my work looks at applied cryptography and things like TLS. I do a lot of work on online privacy and tracking. But I would argue that probably the primary thrust of my research for the last 8 years or so has been this new thing that we call algorithm auditing. So what is that? So this is the application of data science techniques and a little bit of reverse engineering to try and examine primarily the big online platforms to understand what's the data that they're collecting, and then how does that data end up impacting kind of the outcomes of these systems and the way that they affect our lives. So I'll argue that this is, I think, very important because these platforms are typically very opaque. We don't know necessarily what data is being collected or how it shapes what we encounter on the internet. So I can tell you a little bit about some of the prior audits that we've done. One thrust of this work has been looking primarily at political information and how it's disseminated. So we've spent a lot of time looking at Google search and increasingly things like YouTube to see how they present political information. What is its valence? Is it extreme or is it centrist? And is there misinformation or things like hate speech baked into this? Another thrust has been looking at online marketplaces. So we've looked at things like Amazon and how they implement the buy box algorithm. We did some really interesting work looking at Uber and Lyft and the surge pricing systems. We've looked kind of at price personalization and price discrimination writ large in major e-commerce sites. At one point, I did a study for the European Commission where we were looking at price discrimination by theme parks, and that led to an action against Euro Disney. But the topic for today is specifically going to be focused on bias and discrimination. So we've done a number of studies in the past looking at different contexts where algorithms are being used in labor markets. We've tried to look at, based on the kind of data collection, the data that's being collected in those systems and how it's applied, do those systems have bias issues. Are there systematic problems with the way that women are being presented or people of color are being presented that may harm their employment prospects down the line? So I can give you a couple of quick previews of what some of that work looked like. So at one point we were looking at gig economy platforms. So this is a screenshot from a service called Taskrabbit. This is a kind of service where you can go and hire people to do little odd jobs for you. So if you need a dog walker or you need someone to paint your deck, right? You can go here and you search and they'll say, these are the workers, and then you can hire them. So one of the interesting things about this service is that you can provide feedback for the workers that you hire. You can give them a star rating and you can write a little review for them. So we downloaded those ratings and reviews. And unfortunately, what we saw was that those ratings and reviews had strong correlations to demographics. So in particular, women and people of color received less feedback overall, and that feedback tended to be more negative. So, I mean, this is bad, but it's also not unexpected. We know that people harbor these kinds of conscious and unconscious biases, and it's not terribly surprising to see that kind of reflected online in this feedback. What was more interesting and perhaps more concerning about this was that when we looked at the search results, what we saw is that there were also strong correlations between rank in the results and demographics. So this is a representative screenshot. What tended to happen was that white men would appear higher in the search rankings. And the reason is that the social feedback was being used to determine how to order the workers, right? You have someone who searches for dog walker. There's a bunch of potential workers who could do it. How do you order them? Well, some engineer in the back said, well, we should order them by the star rating, right? That makes sense. The best worker should appear first. But clearly they didn't think about what the implications of using that review data would be. So another study we ran looked at resume search engines. So we were in particular looking at Indeed, Monster.com, and Career Builder. These are sites where people seeking employment can go and upload their resume. And then there are recruiter-facing search tools. So a recruiter can go on one of these sites and say, I would like to hire, let's say, a software engineer in Boston. Show me all the people who are related, and then you can call them and interview them. So in particular, in this study, we were focused on gender discrimination. So in other words, our candidates who are likely to be female appearing at lower ranks in the search results. So what these results are showing is the results of some regression tests we ran, where we had downloaded hundreds of thousands of these resumes and run correlations between the various different features of the resumes and then the probability of being masculine of each candidate based on their first name versus their position in the search results. So but our results in the study were a bit of a mixed bag. We did see strong, statistically significant correlations between masculinity and rank. So it was likely that if you were a man, you did have some advantage and it did appear slightly higher in search results. But the effect size of this was very small. So if we only consider, let's say, the first 50 search results, the actual degree of change is less than one position, right? So it's essentially negligible as long as the recruiters are only looking at the top 50 candidates. If, however, recruiters are looking farther down in the search results, this is where the effect size starts to matter. So if you have, let's say, a man and a woman with the same resume, the tie will be broken in favor of the man, right? They will appear at a higher search rank. So the point of this work is really to get at these issues of transparency and accountability. If you follow the news media, it's increasingly apparent that these applications of machine learning and AI can go horribly awry if you're not paying attention, right? We sort of understand now that data is not neutral, data has inherent biases to it. And if you're not careful, those biases get reflected and compounded by these kinds of socio-technical systems. So my argument is that auditing is really important as one part of kind of a comprehensive solution to these AI bias issues. So the idea is that the algorithms that you're using, the data that you're applying should really be vetted by nominally independent experts to make sure that whatever you're building, you haven't had some kind of oversight, or there's no negligence, that what you're building is actually fair for some definition of fair. Hopefully by doing this at large scale, it will increase transparency, right? So the results of these audits should be public, so we know what's going on. And then hopefully the knock-on effect is that this increases accountability. You can't hide problems with your systems anymore by just saying, well, it's proprietary and no one can see it, right? You have to undergo this process. You have to have some degree of transparency. And now if there are problems, people will know and there'll be pressure to fix them. So to date, all of the audits, except for one that I have ever done, are what we call permissionless. And what that means is the company did not consent to the testing, right? So when I was looking at Monster or Taskrabbit, the company didn't know. We frame this as a deception study. So we go and scrape the data and analyze it. And then after the fact, we reveal the results to the company. So prior to the audit I'm going to talk about next, we had never worked with a company to actually audit their system with their own permission. And it was unclear how to even structure such a task. How do you do that in a way that maintains some nominal level of independence between us, the auditor, and the company that is the subject of the audit? So this all changed last summer when we were contacted by a company called Pymetrics. So Pymetrics is a startup running out of New York, and they're part of this group of companies that are now trying to apply machine learning and AI to the problem of candidate screening. So they run this gamified platform where a company will say, let's say we want to recruit software engineers. Here's information about our best engineers. And then Pymetrics will have candidates for that job play games, and then they'll use machine learning to try and figure out whether the people who are applying are a good fit for this job based on the results of the gameplay. So an important part of Pymetrics' mission is that they're very interested in increasing diversity, and they've made pretty strong claims in the past about the fairness of their systems, that is supposed to be baked in from the get-go. It's not supposed to be discriminatory. The question, of course, is, does anyone believe that, right? You can make all the claims you want, but many companies have made such claims, and those claims have fallen flat on their face when put to the test. So Pymetrics approached us asking if we would be their independent auditor. So actually looking at their code, looking at their data, and trying to figure out whether the actual implementation matches the claims that they have made about the fairness guarantees. So this was a very interesting opportunity to us. We've been looking for a chance to work with a company and get insider access to a system like this. Pymetrics is even more interesting because it's not the kind of system that we could run a scraping study of. So the only way to audit this would be with their permission. It's interesting because this is hiring, so it's a heavily regulated space, and the rules of the road in terms of discrimination are fairly well delineated, which makes the kind of criteria of the audit a little bit more straightforward. And as I said, they've made these strong claims, and that gives us kind of a baseline for assessing whether they're doing the right things or not. So this was very interesting to us, both in the sense that we want to run an audit of this particular company because it's an interesting system and they've made strong claims about it, but also from the broader sense of this is an opportunity to try and set up some kind of a model for how an independent research group should work with a company to run an audit and think through these complex issues about scoping the audit and maintaining our independence. So we did this audit. The results are published in a paper at the ACM Conference on Fairness, Accountability, and Transparency, otherwise known as FACT. So the contributions of this work are the following. Some of them are sort of technical. So we describe how the Pymetrics algorithm works and how they implement adverse impact testing. We documented the process for our audit, and obviously we present the results of the audit. So did this company pass? But there are also these broader impacts. So this is one of the first examples of what I'm calling a cooperative audit, right? It's not permissionless. We didn't audit them without their permission. We worked with them. So the hope is that by showing that this can be done in a way that's sensitive to the company's secrecy around their algorithms, but still maintains some level of independence, we can encourage other companies to agree to this kind of auditing. And we've provided a sort of a playbook for how to think through some of these issues of scoping and independence and maintaining this security of things like proprietary information. So I'll talk a little bit about how Pymetrics works under the hood. So what are their algorithms doing? I'll talk about the design of our audits. I'll give you the audit results. So what did we actually find? And then some of the high level conclusions of this work. Okay, so let's start by talking about Pymetrics. So Pymetrics has said publicly that the way they implement fairness in their algorithm is that it's based on trying to achieve a rough predictive parity based on the Uniform Guidelines 4/5 rule. So this is a guideline from a US regulatory agency, and it roughly says that the pass rates for an employment selection process for the lowest passing group divided by the pass rates for the highest passing group must be above 80%. So the particular groups that they're concerned about are binary gender, so male, female, and then a set of sort of prescribed race and ethnicity categories. The guidelines also talk about age, but Pymetrics doesn't implement testing for age. They only look at binary gender and these racial categories. So the way that they actually implement this is the following. So I'll give you kind of the high level sketch, and then I'll give it to you again with more detail. So the idea is the following. So they're going to be taking data and training a model, and that is done without demographic data. So the model is blind to gender and race. They then evaluate the model using a held out set of data that does include demographics. So they're basically sort of playing a hypothetical. If this held out set of candidates applied for this job and they were evaluated by this model, would the results of the people who are predicted to succeed pass the 4/5 rule? If the model does not pass, then you go back to step one and tweak the features that are being included in the model, retrain it, and then evaluate it again. So it's this iterative process of train, evaluate, go back and tweak your features, train, evaluate, etc. So this is what Pymetrics says the process is supposed to be, and they have open sourced some of this code, but not nearly enough to fully assess whether this is really how their system works in practice or whether there are any problems with it. So to give you a little bit more detail about kind of how Pymetrics works as a company and as a data science pipeline. So their whole shtick is that they're providing this machine learning powered service for screening candidates. So the way that starts is that a client will go to Pymetrics and say, we would like to hire people for some kind of job role. And then it's up to the client to provide Pymetrics with 2 data sets on their incumbent employees. So let's say they're hiring a software engineer. The company would have their top performing software engineers play the Pymetrics games, right, to produce a gameplay data set. And the company would provide their own set of performance data for those employees. So that could be based on, let's say, quarterly assessments or yearly reviews, or it could be hard data, so things like sales numbers or marketing numbers or whatever. So that data then gets fed into the model training pipeline. So Pymetrics is training a model per client, per job role. So what data goes into model training? So this includes the data that the client provided, and these are the positive labeled examples. For the negative training examples, Pymetrics will draw from its existing database of people who have played the games in the past when they applied for other jobs at other clients. So this is just a huge data set of gameplay, millions of people, and they'll select some large random subset of that. So those become the negative training examples. So at this point in the process, no demographics are used. There's no race, there's no gender, there's no ethnicity. None of that is known at training time. Right, so we have the data from the clients. So the next step is adverse impact testing to see if the model that was trained complies with the 4/5 rule. So this is looking for compliance with gender groups and racial groups. And as I mentioned earlier, this is based on a held out set of gameplay data that does have demographics. So if a model doesn't pass, then they go back to training, they modify the set of features, they retrain, and then they reevaluate. You may be wondering where the demographic data is coming from. So that's all self-reported. So when people apply to jobs through Pymetrics, they play the games, and they're also given an opportunity to take a demographic survey so they can self-identify as a man or a woman or their race. And I think roughly 75%-ish of the people who apply actually take the survey. So it's a pretty robust set of people. So finally, assuming that Pymetrics can find a model that complies with the 4/5 rule and has high predictive performance, that model will be deployed. At that point, people can apply for this job. They will play the games and optionally provide demographics. And then based on the results of their gameplay, the model will predict whether they're a good fit for this job or not. The high scoring candidates are sent to the employer, and then they can be interviewed. So there's a big feedback loop going on here, right? This gameplay data from these future candidates ultimately gets fed back into training data for future model builds. And then the people who do choose to disclose demographics, they're also providing data for future adverse impact testing, right? They can be part of this held out set. So our focus in this audit was really the orange box, right? The adverse impact testing. They've said how this should work. Does it actually work this way? So for those of you not familiar with employment law in the US, you may be wondering why the 4/5 rule. So the Pymetrics has spent a lot of time talking to people from the EEOC, the Equal Employment Commission, and they have a whole team of lawyers who've looked at jurisprudence in the US about employment law. So based on their best interpretation of the existing legal statutes, they felt this was the best metric to implement. It's part of the guidelines that are promoted by the government, and it's widely accepted by judges in employment discrimination cases. Now, I'm not going to argue that the 4/5 rule is good. I actually think it's very, very bad, but at least it is defensible legally, which is why Pymetrics chooses to use it. So let's move on to our audit. So when we were approached by Pymetrics, there was a couple of key challenges that we knew we would immediately face. One of them was establishing the scope of our audit. So what are we exactly trying to assess? And we want to make it very clear, this is exactly what we looked at, but these are also things that we didn't look at. So the other issue, of course, was maintaining credibility, right? It's easy to maintain credibility when the company is totally unaware of the audit. But in this case, the company knew. So how do we make sure that our evaluation is seen as credible given these kind of changing circumstances? So with respect to the scope of the audit, we settled on 5 things that we were going to test. And of course, we didn't tell Pymetrics any of this ahead of time. So the first and biggest thing is correctness. So does Pymetrics' implementation follow what they have claimed it should do, right? Is it implementing the 4/5 rule faithfully? Second, we wanted to look at direct discrimination. So they claim that their models aren't trained using demographic data. Is that true or not? Third, we wanted to look at socio-technical safeguards. So the Pymetrics pipeline is not a fully automated process. For every model they train, there's a data scientist who sits down and actually builds it more or less by hand. And that's fine, but it means that there's the possibility now of human error or human negligence. So we wanted to make sure that there was a robust process for making sure that a human error would not result in a biased model being deployed. Fourth, we wanted to look at debiasing circumvention. So this is essentially an adversarial attack. What if a client were to provide Pymetrics with intentionally biased training data? Could they somehow get Pymetrics to train and release a biased model without them realizing it? Fifth, we wanted to look at some of the deep assumptions baked into Pymetrics' system. As people who are data scientists understand, taking a data set and applying machine learning to it is never straightforward. There's all kinds of assumptions that get baked in about data cleaning, and imputation, and normalization. How do you choose the subset of data you're going to work with? All those choices have value-laden normative consequences potentially. So, are there any assumptions getting baked into Pymetrics' model that could unintentionally result in biased models getting built? So just as important as understanding what we were going to test was really clearly delineating what we were not going to test. So we had conversations with Pymetrics about this, and very early on we agreed that we were not going to question their definition of fairness, right? So we just accept that they say they're doing the 4/5 rule, and that's going to be our baseline for evaluation. We didn't attempt to look at any other definitions of fairness. We basically just accepted, their lawyers have vetted this. We're not going to question, the competency of their legal team. So another thing that we didn't look at is end-to-end predictive validity. So the question here is, are these gamified assessments actually a robust way of predicting whether someone will be good at a job or not? I think that's a super interesting question. I hope they eventually do audits of this nature. But at the end of the day, we are not domain experts in this kind of assessment. I'm not a cognitive psychologist, and we're just not equipped to answer this question. We only looked at one Pymetrics product, this candidate screening tool. And this was not a cybersecurity or privacy compliance audit. So we're not talking about GDPR. We're not talking about any of those things. We're just talking about the fairness of this model training pipeline. So with respect to maintaining our credibility, there's a number of important issues that we had to sort of work through. So one thing is that, yes, we were paid to conduct this audit. Initially, Pymetrics wanted to pay us as an independent consultants, but ultimately we steered them instead to a grant arrangement. So Pymetrics wrote a grant contract, the money was sent to Northeastern University, and then we used that to pay for our students and our time. So we, keep this in mind, right? This is not, pro bono work. Ahead of time, we spent a lot of time thinking about how we were going to maintain secrecy during the audit. So we didn't tell them ahead of time what we were going to be testing or how we were going to be doing the testing, because we didn't want them to, give us data, that would bias our outcomes in any way. One really important thing is that ahead of time, we signed contracts with Pymetrics, and in those contracts, we maintained the right to talk and write about the audit, more or less carte blanche. So we're not allowed to talk about the specific source code that we saw and the sensitive data that we saw. And there's a couple of small aspects of Pymetrics' algorithms that they consider to be proprietary that I'm not allowed to talk about in detail. But beyond that, I'm allowed to say whatever I want. So even if Pymetrics failed the audit and we found horrible problems, we're allowed to talk about that. We would not have agreed to the audit without this capability. So that said, we did agree to a 30-day responsible disclosure period. So if, for example, we found some horrible problem, we agreed to tell them ahead of time privately and give them a chance to remediate before we went public. So this is based on kind of standard practices from the cybersecurity community and how you reveal exploits to companies. And we felt that this was just the ethical thing to do. So with respect to maintaining the transparency of our audit, beyond just those narrow things like source code and the proprietary pieces of their pipeline, we've tried to be as transparent about this as we can. So if you go to my website, you can see all the contracts that we signed, the project budget. It's all right there in the open. Obviously, we co-authored a paper with the Pymetrics folks, and that paper is public. The white paper that we produced for the results of the audit that we gave to Pymetrics, that's on my website, so that's public. With respect to the authorship of the paper, so it is co-authored between us and Pymetrics. What that means in practice is that the Pymetrics staff primarily wrote section 3 of the paper, which is about their algorithms, and they contributed to the conclusions of the paper. But everything else, in particular, the things about the audit and the results of the audit, were all written by us. So I'll briefly walk you through some of the results of the audit. What did we actually find? So if you recall, we had these 5 key questions that we wanted to look at. So the first was just correctness. Does Pymetrics' algorithms actually match their documentation and their claims about the system? So we just spent a lot of time digging into their source code. And what we found is that their claims were true, right? So the source code that we saw faithfully implements this adverse impact testing using the 4/5 rule. Everything they said about how the testing was done matched what we saw. It seemed to be correct and bug-free. So they passed this part of the audit. With respect to direct discrimination, so we looked at the model training pipeline, and we confirmed that all of the data sets used for training do not include demographics. So there is no direct discrimination. The training data is demographic blind, at least in the sense that those features are not being included directly. With respect to socio-technical safeguards, so could human error result in a biased model being deployed? We were actually pretty impressed. So when Pymetrics data scientists build one of these models, at the end of that process, they have to go through an extensive checklist review where they have to reassess all their work. They have to justify all the decisions they made about designing the models, including or excluding features, any deviations from the normal procedure. That whole checklist, all the data sets and the resulting models, that then gets re-reviewed by a second data scientist to make sure that everything matches up, that there's no sort of weirdness or anomalies. And only then, after this 2-person review, can a model actually be deployed in practice. So is this a guarantee that an erroneous model could never be deployed? No. But in our expert opinion, this seems like a pretty robust procedure. This is about as good as it will get. So we say that Pymetrics passed this facet of the audit. So with respect to debiasing circumvention, right? So this is the issue that comes up because clients are supplying a portion of the training data, which means that a malicious client could, in theory, supply metrics with intentionally biased data and try to influence the outcome of model training. So to dig into this, we actually played the role of an attacker. Right, so let's imagine that Christo Wilson Corporation would like Pymetrics to train a biased model. Maybe I only want to hire white men for some reason. So could I supply Pymetrics with intentionally biased data so that they will train a biased model and then deploy it without even realizing it? So we actually tested this hypothetical scenario. So we went through all the data that Pymetrics had given us, and we created these intentionally biased subsamples of data and tried to use it to train models. So we did things like we would subsample a data set of all white men, or we would subsample a data set of all one white man, or we would take one white man and just slightly perturb him, by giving him a mustache or sunglasses or putting a mask on him. So the outcome of all this testing was that we couldn't get their pipeline to fail. So what I mean by that is either the pipeline would not be able to produce a fair model that met the 4/5 rule, and at that point the data scientist would look at it and say, task is impossible, we have to go back to square one and get better data. Or the alternative outcome is that the model training pipeline would actually be able to identify features that were predictive, but were also not correlated with demographics. So even though I'm intentionally supplying a biased training data set, the model pipeline would actually still find an unbiased, fair model, and it would succeed in producing a model that's predictive but fair. So either way, our attacks failed. Either I get no model, or I get a model that's fair when I wanted an unfair model. So these attacks failed, which is good for Pymetrics, right? We would say they passed this portion of the audit. So the final step was looking at the assumptions that were baked into the lowest levels of their model training pipeline. So in particular, the thing that we focused on the most was imputation. So the scenario here is that you have candidates who are playing these games, and the candidates, for a variety of reasons, may not produce all the data, right? So you can imagine that, I think Pymetrics has about 10 different games. You could have a candidate who only plays 9 out of the 10 games. Or you could have a candidate that starts a game but doesn't finish it. So it only produces a portion of its data. So this is a common problem with any sort of machine learning scenario. There's going to be missing values, and those values have to be imputed. So we started by looking at just sort of writ large whether imputation could have an effect on the ultimate outcome of model training. And we saw that it could. So that we saw that there were statistically significant correlations between the missing trait distributions and demographics. So in particular, like African-American candidates tended to be missing more values, meaning they would be more impacted by imputation. The other thing that we saw was that there were statistically significant correlations between the gameplay data and demographics. Right? So there were slight differences in how men and women played the games, and slight differences in how white people and Black people and Hispanic people played the games. So at the time when we were looking at Pymetrics' code, they were using median imputation. So for a given gameplay trait, right, they calculate the population median, and then they use that value to fill in all the blanks. That's not great if every group has a slightly different median. That means, for example, like Black candidates, any missing values are being set to the population mean, when in fact their subpopulation mean is a little bit different. So it seems like, based on these statistical correlations, the choice of imputation could ultimately impact the outcome of the models. So what we did is we went through and tested a bunch of different imputation techniques. So what I'm showing you here are tests where we trained the models using data that had been imputed using median imputation, right? So that was Pymetrics' default implementation at the time. But then we tested the models for fairness based on data that had been imputed using a different model. And in fact, we saw that most of the other imputers produced data that was actually more accurate. So for example, the blue line is Pymetrics' default. So that's median imputation and then median evaluation. But then, for example, the orange line is median training, but then using a Bayesian ridge regression for imputing the data for testing. So even though we saw statistically significant correlations between these different kinds of facets of the data, what we see in practice is that this didn't have an impact on the fairness evaluation. So the x-axis here, you have the acceptance threshold. So this is the point at which you say the candidates are strong enough to be considered for employment. And on the y-axis here, we're looking at the minimum bias ratio. So this is, as long as the model is above 0.8, we would say it complies with US law and it would be fair. With the sole exception of the pink line, so the KNN regressor, at an acceptance threshold of 90, the models basically have the same fairness across the board. So this is a classic scenario where it's a big data set and it's easy to find statistically significant correlations. but the actual effect size of this is apparently nil, right? It doesn't actually have a substantive impact on the fairness guarantees of the models. So in practice, Pymetrics typically uses an acceptance threshold of 70, right? So at that point, you can see that these models basically have the same performance in terms of fairness. So overall, we would say that Pymetrics passed the audit, right? The assumptions baked into their algorithm don't result in biased outcomes. Everything else looks good. So to briefly conclude, we would say that Pymetrics passed the audit. I guess this isn't so surprising. They probably wouldn't have agreed to let us do this if they thought there was a chance of them failing. That said, just based on the results of the audits, Pymetrics did make a number of improvements to their pipeline. So they moved away from median imputation. They're using a much more sophisticated imputer now. They also changed how they did sampling for their unlabeled negative training samples, as well as their bias evaluation set, to more carefully construct ones that are related to a particular job role. So they do some additional filtering now based on language and region and job type. So one of the fascinating things that happened is at the same time we released our audit of Pymetrics, there was another audit released of a similar company called HireView. So that audit was conducted by a consultancy called Orca that's run by Kathy O'Neill. So she's the author of the book, Weapons of Math Destruction. And these two audits are a fascinating study in contrasts. So as you've heard, our audit was primarily technical. We spent all our time, in the guts of their source code and their data. But one thing that we didn't do is this kind of broader stakeholder mapping. So we didn't talk to Pymetrics clients. We didn't talk to candidates who had played the games. We didn't really get into the broader socio-technical context of their system. The Orca audit is the exact opposite. So they didn't look at HireView's source code or data at all. They just asked them to self-certify that their systems were fair. But in contrast, so Kathy O'Neill spent a lot of time talking to different stakeholders, HireView's clients, people who'd done the HireView video interviews, civil rights organizations, et cetera, to talk about their concerns about the design of this system and what HireView could do to try to mitigate some of those concerns. Neither audit looked at end-to-end predictive validity, right? So neither of us looked at whether either of these tools were actually good at predicting who should be a good employee or not, which is somewhat unsatisfying. But that said, both audits did have positive outcomes in that they did lead to changes in these systems, that I would argue improved them. So I think this is really interesting because, in the future, what I would hope is that audits will kind of combine the best of both worlds, right? I think audits do need to have this deep technical aspect. I don't think it's okay to just ask a company to self-certify that their systems are fine. But an audit shouldn't stop at just the technical details, right? Everything is more powerful when you have this broader sociological understanding of how this thing is actually being deployed and its effect on people in practice. So, the HireView audit and the Pymetrics audit, I think, are really interesting because they point to this future where you can have cooperative auditing. And what this leads to is a kind of a spectrum of different kinds of audits that we may have. My prior work, as I said earlier, is mostly these permissionless audits where we look at systems without consent. And I think those studies are always going to be really important because there will always be companies that refuse to consent to an audit. On the other end of this spectrum, there's a really nice paper from FatStar in 2020 from Raji et al. Where they talk about internal auditing. So they lay out a really nice process for how companies should be auditing their systems internally in tandem with system development. And I think that's really important too. Companies should have an awareness of these problems and be proactive about trying to make sure that their systems are fair and equitable. The work I've just presented today really falls in the middle, right? It's not an internal audit. We're not Pymetrics employees, but it's also not permissionless, right? We had insider access and we were paid. So all of these different modes of work, I think, are really useful and powerful. And I think it's really interesting to see kind of development of this whole space of audits. So with that, I will conclude, and I'm more than happy to take questions.
Thanks a lot, Christo. That was super interesting. And thanks also for being so sharp in time. Okay, so then we have an open session for Q&A. We already have one question. Do you have information on or consider the diversity of the engineering team? That seems to be a source that can influence the potential bias in the algorithms.
Yeah, so that's a really good question. We didn't specifically ask these questions, and this is a failure on our part because we didn't perform this kind of stakeholder mapping. Right, the employees at the company building the system are clearly one of those stakeholders. So that said, of the Pimetrics employees I talked to, I think we talked to about 8 different employees there, 6 of whom were women. So the CEO is a woman. The number 2 data scientist is a woman. Janelle's a co-author on the paper. So I get the sense that they do have somewhat reasonable diversity, at least along gender lines. But in terms of racial and ethnic diversity, I don't know. And it would be nice to know that.
Thanks a lot. While we are waiting for other questions from the audience, so let me just ask myself. I find what you said really very interesting. So as an economist, I'm trying to see how these auditing activity may evolve as a market. Mm-hmm. So I would like to have your opinion on this, and in particular, if you can tell us about how this auditing process that you performed can be a scalable process. Mm-hmm. How much is specific to the company that you audited, and how much there is a really hot debate nowadays, especially in Europe, about the issue of transparency, explainability, interpretability. There is a lot of talk in there. There is a need of more transparency, as you say. But I'm really asking myself to what extent this can be actually taken to the market or to some scalable dimension.
Yeah, so there are startups who are now claiming to offer auditing. There are these little boutique consultancies. But I know Accenture is also trying to get into this market. So there's clearly interest among the big consultancies. Especially as we hear regulators talk about auditing requirements, it does seem like there are companies just waiting in the wings to capitalize on a legislated demand that people must engage in these practices. So in terms of scalability, I would say it's a bit of a mixed bag. So every company is going to show up with their own kind of source code and data science pipeline. And there's no getting around the fact that someone is going to have to look at that code and manually dig into it for things like, are there bugs? Does it match claims? There's just no easy way of getting around that, that's manual work. That said, I think that the auditing process will get easier as more people engage in the work that the work that we just presented. You can certainly have a guidebook for how to proceed. You should do a stakeholder mapping. What does that mean? Who are the kinds of groups you should talk to? Who should talk to them? It shouldn't be your data scientists, right? You need sociologists, you need anthropologists. And then even on the data science side, what are the kinds of fairness metrics we should be evaluating for? What is the legal landscape in a given country? what are the baselines that we should be measuring towards? This kind of output-oriented testing, I think a lot of that can be automated. It's, you have to do a little bit of munging to get the data into it. You have to get output from their model. But ultimately, the outcome, we know what the outcomes should be. You just need to assess them. So I don't think that this will ultimately be like an entirely bespoke industry, but it will also never be turnkey.
Thank you. So we have another question. It's interesting that even with the data poisoning attempt, the model still performs well. Does that mean a model-centric approach can work better than data-centric approach in some cases? It seems to hear more news about data being a source of bias.
Yeah, so the reason that Pymetrics, why their system survives the test, is because of the way they do the adverse impact testing. So the adverse impact testing is all post hoc, right? They train a model and then evaluating it using a separate data set. And we weren't able to poison the bias testing data set, right? The client data that we can poison is only used for training. So this is actually an advantage of doing adverse impact testing this way with the post hoc testing. It more or less makes you resilient to this kind of poisoning. But that said, it's also a bit unsatisfying, right? With that kind of post hoc approach, you can never use the kind of fair by design models that are now more popular in the literature, where the fairness criteria are baked in as objectives at training time. So Pymetrics will probably never be able to get to models that are 100% fair because it's not baked in. If you wanted that, you'd have to go with a fair by design model, and you'd have to train with the demographics being known. But that also means that poisoning at training time would have a much bigger impact. So, I mean, it's very interesting, the trade-offs here of legal compliance, at least in the US, that says, say you can't train on demographics. So you have to do post hoc testing, and that makes you a little bit more robust to an adversarial attack. But it also constrains how fair you can make the thing. So maybe future techniques will be able to blend all of this together, but at least for now, I don't think we have a way of doing this.
Thank you. We have another question. Even if the company is audited, if they provide service/product to other organizations, the work may lose contextual integrity. So what kinds of practices, policies could be put in place for distribution to the last mile in a data analytics supply chain?
Yeah, I mean, this is a crucial question. We did an audit at a point in time. So the thing could change after the fact. And Pymetrics does offer, for example, bespoke model training. A client can come and say, we want a different fairness metric, or we want fairness for different groups. And again, that's beyond the scope of our audit. So to a certain extent, I think we're going to have to rely on periodic auditing, first of all. So this is never a one and done process. The other thing is, I think we have to accept that at some point, a company that's willing to undergo these audits and is acting in good faith, we have to just accept that part of the point of that audit is to accept kind of the robustness of the process rather than the robustness of a particular data set or a particular source code. So when Pymetrics goes and does a custom client engagement, I would trust them to do the right things because they've demonstrated that this is something they care about. Is that going to guarantee perfection? Of course not. But at least we sort of know they're a good actor. I'd be much more concerned about a company that had not undergone any auditing at all. Just even if they claim to be saying things that are fair, it's not clear how robust their processes are or whether this is being done in good faith. And then it just gets even more complicated as you change context, as things become more bespoke.
Thank you. I have myself another question. It's, I would say, a rather general question, but I think it's refers to the approach that we use at CIVICA, which is, as I mentioned at the beginning, interdisciplinary. So if you think about your experience with this auditing activity, what would be the limitation, if any, that you may have encountered in doing this activity with the team that you had been working with? Do you see any specific skills that you would like to have complemented with?
Yeah, so I mean, there's a big limitation here. We were all computer scientists. So the code and data and analytics part, we were very comfortable with this. You know, it might have been nice to have a statistician as part of the group to really double check, you know, all of our statistical testing. But actually, I think our big limitation is that we didn't have sociologists, we didn't have cognitive psychologists, we didn't have anthropologists. So if we had wanted to do this kind of stakeholder mapping, we could have done it, but it probably would not have been very good. Or if we wanted to look at these more pointed questions like, do the games have predictive validity, or is this pseudoscience? We're not equipped to do those kinds of tests at all. You know, I would want cognitive psychologists. I'd want people who are experts in, you know, employment assessment. We'd have to have an interdisciplinary team. I mean, there's just no way around that.
Thank you. We have another question from the audience. I'm interested in how did you determine which features to poison in the attack? For example, did you pick up among those with high feature importance? Overall, is this a good model agnostic approach for modeling auditing?
Yeah, so the Pimetrics models are surprisingly simple. The games only output 64 features. So this is not, you know, a high dimensional neural model where we don't know kind of what the inputs really mean. So we did vary the way we were doing perturbation by focusing on different classes of features. You know, those are the cases where it was easier to get the pipeline to fail. You know, so if we focused on the most impactful features, the pipeline would not be able to find an unbiased model. There was just way too much correlation between the most important features and being a white dude. In the cases where there was not so much focus on the you know, features of high importance, and it was just more evenly distributed noise, those are the cases where it could find something that was still predictive and fair, despite the fact that we had given nominally biased training data. So, you know, I'm not going to argue that these poisoning techniques were sophisticated. They were not. You know, this is nowhere near the state of the art in, say, adversarial machine learning. But at the same time, you know, given that we were attacking a low-dimensional model, I think this was sort of sufficient. I mean, to be perfectly honest, we almost didn't do the tests at all because we knew what the outcome would be, given that we couldn't poison the adverse impact testing data.
Okay, so thanks a lot. I think our time is over. Let me really thank you, Christo, for this inspiring and very interesting talk. I'm sure that the folk at CIVICA have really appreciated a lot. So let me thank you again, and let me hand over to the organizers for advertising our next meeting. So thanks again. Thank you, Christo.
Thanks, everybody.
Thank you, Giacomo. Thank you very much, Christo. And just for the benefit of the audience, to let you know that our upcoming seminars over the next couple of months, we have one coming up on April the 21st with Preslav Nakov talking about how to detect fake news. and another coming up on May the 5th with Dr. Melissa Sands talking about using computer vision to detect racial distancing on city streets. So we look forward to seeing you at one of our events in future. Thank you very much to everyone for being here. See you next time.